Recently, an independent bookseller noticed an anonymous order for roughly 1,000 rare out-of-print books. To find out where the package was headed, journalists at 404 Media decided to investigate. They hid an Apple AirTag inside one of the books. The tracker pinged its way across the country, finally stopping at a specific Amazon facility in northeastern Las Vegas. Amazon workers confirmed the site performs destructive scanning. Physical books are mechanically sliced apart so every page can be digitized for an AI training pipeline. The binding is sheared off. The pages are fed through a scanner and then discarded. The original object, often a rare edition that will never be manufactured again, is permanently destroyed. We talk about AI learning as if it happens in an invisible, magical cloud. The reality starts much closer to the ground, with the physical dismantling of human history. Once that data is extracted, processing it requires electricity. A staggering amount of it. OpenAI is currently planning a massive computing facility in Pike County, Ohio. They are securing roughly 8 gigawatts of power. For context, 8 gigawatts is the total output of 8 massive dedicated power plants. To find that kind of capacity, they are repurposing the Portsmouth Gaseous Diffusion Plant. It is a former Cold War nuclear site, originally built to enrich uranium. Scaling this hardware means building at the level of heavy industry. Computing power is now being financed and constructed like massive commercial real estate megaprojects, backed by players like NVIDIA. The hardware required to run these models has completely outgrown standard server racks. It is actively shaping the physical landscape, claiming finite legacy energy infrastructure to feed its demand. Inside those huge facilities, the actual chips running the math, the GPUs, are dealing with a different constraint: severe inefficiency. Normally, GPU jobs are assigned first come, first served. Unequal jobs reserve capacity and sit idle, scattering workloads. Engineers replaced this with a constraint-aware allocator. Software now plans placement in milliseconds, organizing jobs to interlock perfectly. Without installing a single new chip, identical GPUs did 33% more work. Useful, priority-weighted output jumped 105%. The immediate barrier to scaling AI computation is poor engineering efficiency. Sometimes the fix is just writing better software to manage the plumbing. That same mechanical failure shows up when we try to deploy autonomous AI agents. They routinely fail in the real world due to boring permission errors or bad memory access, not because the core model lacks intelligence. The industry is pivoting. Rather than trying to train a single, impossibly smart brain, engineers are wrapping existing models in thick external guardrails, adding recoverable checkpoints and strict permission layers. One method is drift recovery. A smaller, secondary model watches the main agent, aggressively pulling it back into alignment the moment it wanders off track. Reliable, deployed AI does not look like an independent entity. It looks like a heavily supervised machine, hemmed in by mechanical safety protocols to ensure it actually finishes a job. There is a widespread assumption that these autonomous models will inevitably flood open-source software projects and fully replace human programmers. Researchers tracked more than 33,000 merged code contributions across 3 years in major infrastructure projects. They found that fully autonomous bots wrote less than 0.2% of the new work. Here is a chart comparing the sources of new code. The microscopic bot contributions are dwarfed by the massive surge in output directly from human programmers, who are using AI assistants to ship their work up to 21 times faster. The models have not replaced the workforce. They have accelerated human speed. The person sitting at the keyboard remains the ultimate driver of volume. Because generating text and code is practically free, our digital spaces are filling up with raw, unedited AI output. People are actively rejecting this. A movement called AI TDR, which stands for AI Didn't Read, is gaining mainstream traction. The rule is simple. If a creator refuses to apply human judgment to their generated text, the reader is entirely justified in refusing to read it. We pull physical books apart to train the models, and we repurpose nuclear sites to power them. But the final constraint happens on the screen. In a brutalist industrial machine built to manufacture infinite content, human editorial judgment is the single most valuable and finite resource left.